Assalamu alaikum. Today's lecture about capacity planning. What do we mean by capacity? Capacity is the upper limit or ceiling or the maximum on the load that an operating unit can handle. We can measure it for a machine, an equipment, for a space, or for employee skills. The maximum that some room can handle, the maximum of a machine that can produce, and so on. The goal for this strategic decision is to achieve a match between what? The starting point for the production plan is having sales forecast. So we have sales or demand forecast that must be satisfied by providing some quantity of products that require having some capacities, machining hours, working hours, amount of materials, and so on. So this decision tries to make a match between the supply capabilities of the organization and the predicted long-term demand. So it matches between the demand and the quantities of capabilities of the organization through producing some quantity of production. The key questions include type or kind of capacity needed, amount of capacity needed, and timing of such capacity. Capacity decisions are important because the same way as any other strategic decisions, as we mentioned, we have 4 questions and 5 answers. What to produce, the answer is product design. How much to produce, the answer is capacity decision. How to produce, process planning. Where to produce, the location and the internal layout. So the importance of the capacity decision is or include factors the same as the importance of any other strategic decision for designing a production system. It impacts the ability of the organization to meet future demand. It affects the operating costs. It has a very expensive initial cost, often involve long-term commitment of resources, can affect competitiveness, can affect the ease of management, have become more important and complex due to globalization and other factors. How can we define? This is an important point. How can we define and measure capacity? Measuring capacity may be in terms of units produced or units of inputs used. Okay, we will talk in details about it. And the other type of measurement having useful functional definitions of capacity about design capacity and planned capacity. Starting with the first type of measurement, measuring capacity in units. The load or the capacity can be represented using, firstly, the default is due number of outputs produced, saying that we can produce 20 units of product every an hour or per day or per some specific period of time. Okay, 20 units per hour. This is a measure or a good measure for capacity through using the quantity of outputs produced. Otherwise, we can use amount of inputs used to represent the capacity, saying that 45 pounds of raw materials can be processed every hour. So we can use number of units produced as outputs or number of units used in inputs. Why we have some problems or difficulties of finding a suitable measure? What are the problems about using outputs as a measure for capacity? What if the organization produces more than one type of product? For example, producing washers and refrigerators. Different types of products cannot be added up. So in this case, we use total capacity in terms of each product, which means assume that all the capacity, all the machining will be used in producing one type of product only, as if we about to translate all capacities of one product to the other one. But what if we have frequent changes in the product mix? We changed one product, for example, we changed the refrigerators into washers. So we assume that all capacities will be used in producing washers only, not washers and refrigerators. What if the organization frequently changes their product mix? For this case, we have to use the dollar value or the monetary value. We face another problem if we use the monetary value. Prices are changing, which requires updating the mix. So at this case, we have to change in using inputs. Any type of used inputs can represent capacity, number of workers, number of machines or machining hours, amount of used materials. Any type of basic input used in the production process can be used as a measure of capacity. Then, on the other hand, we have some other useful or functional definitions or measurements of capacity. Let's talk about an example. Having a car, what is the speed for this car? We have three types of speeds. The first one, the design or the catalog speed, which represent the maximum that can this car go up till under ideal conditions. And we have some other planned speed that we are going or planning to use during some specific trip. But finally, we have actual speed that occurred actually. So we have design or catalog capacity. We have planned capacity, the same for the machining. We have design that the producer or the designer of the machine has mentioned that it can produce up till maybe 1,000 units per shift. Then we have less amount of capacity representing planned or effective capacity, and the smallest of them is the actual output produced. Let's define each of them. Design or catalog capacity means the maximum output rate or service capacity an operation or a process or a machine or a facility is designed for. So this is the maximum output rate under ideal conditions, which are not in real life. So these ideal conditions are not real conditions. So it represents the maximum that can be produced if we have some optimum or some ideal conditions. but actually we plan some specific capacity level, which we call it planned capacity or effective capacity. It's lower than or less than the design or the catalog capacity. So it equals the previous capacity or the maximum rate of output, which is functional or design capacity minus. So it is less than the functional, the design capacity by some amount of what? Planned stoppings, planned stops, planned allowances. We are planning to stop the machines for some reasons. These amounts of stopping the machines are reduced from the design capacity to give the planned capacity. What are the planned stops or allowances? Lunch times. We are planning to stop the machine. Having, for example, the shift is 8 hours. We are not operating the machines for or the whole factory for the 8 hours because we have some breaks, we have some lunch time that the machine and the worker will not be available for the production process. So it reduces the amount of production through the lunch times, through changing product mix. Producing product A on the machine, when we are done with product A, we have to stop, prepare, or set the machine up to be ready for producing product B. So changing the product mix requires stopping machines in planned allowances or stops. We have to stop the machine to conduct the maintenance or for balancing operations. What do we mean by balancing operations? We will talk about it with the concept of bottlenecks, how to manage bottlenecks. The other type of capacity is the actual output, which is less than the planned capacity. The actual output we have will be less than the planned capacity. So it is, or it represents the rate of output actually achieved, called planned capacity minus, equals planned capacity minus, equal the previous capacity minus unexpected stops. For example, absenteeism, having some over level, some excess percentage of absence higher than the expected or planned absence rate or regular absence rate, or because of sudden breakdown of machines. These are unexpected stops, or because of material shortage. Think about a workstation. What do we mean by workstation? A place where the production process occurs, including a machine, materials, and manpower. Any absence of one of these three elements means the workstation will not be operating. Absenteeism means unexpected absence for the labor. Breakdown means unexpected absence for the machine. Material shortage means unexpected absence for the materials. Having defective output that requires reproducing or recorrecting the defective units that we have produced, which means the machine will be used in reproducing or recorrecting the defective outputs or the defective units. So, as we mentioned, the maximum capacity rate represented by design or catalog capacity. Then, when we plan at lower level than the catalog capacity. Planned capacity equals catalog capacity minus planned stops with the previously mentioned examples. Coming to the actual equals the planned capacity minus unexpected stop with the mentioned examples. We have another two measurements or criteria to measure effectiveness and efficiency of some operating system. The actual output, the rate of output actually achieved cannot exceed effective capacity. This is the actual efficiency, as we mentioned, equals. What do we want through using these ratios? We have actual output we have achieved from the production system. We want to assess or evaluate these actual outputs. How can we compare them? We compare them either by dividing on planned capacity, actual divided by planned, or we will divide the actual capacity by design or catalog capacity. So we have two ratios, efficiency that equals actual divided by planned, and utilization rate equals actual divided by catalog design. So the ratios, efficiency equals actual output divided by planned capacity, while utilization ratio equals actual divided by catalog or design capacity, multiply by 100 to give a percentage. Okay. For example, having a design capacity equals 50 trucks per day, planned capacity 40 trucks per day, actual capacity 36 units per day. As we know, or as we observe, the actual is the lowest one and the design or catalog capacity is the maximum one. Calculate efficiency and utilization ratio. Efficiency equals actual divided by planned, 36 divided by 40 times 100 to give 90% if we want it as a percentage, while utilization equals actual divided by design equals 0.72. So as we observe, the efficiency ratio gives higher value, although we evaluate the same amount of actual, 36 units per hour. But when it is divided by planned, it gives higher percentage, 90%. And when the same actual amount, 36 units per hour, is divided by the design capacity, it gives lower ratio or lower percentage. Why? Because the planned capacity is less than the design capacity. So most of the managers prefer using the efficiency ratio because it gives misleading higher values than the utilization rate. For example, the previous example, you were given the three amounts of capacity, catalog, planned, and actual, and you are required to calculate both ratios, efficiency and utilization. This example is different. You are not given the actual amount of output. You are given design capacity planned capacity and one of the ratios, and you are required to calculate the other ratio. If a new product line has design capacity of 12,000 units per year, planned capacity 10,000 units per year, efficiency ratio is expected to be 60%. Calculate the other ratio, utilization ratio. Using the formula of the efficiency ratio, calculate the actual. For example, we have the efficiency ratio, we have the planned capacity, but we don't have the actual output. So 0.6, the efficiency, or 60% efficiency ratio, equals unknown actual capacity divided by 10,000 planned capacity. By this we can calculate the actual and then recalculate the utilization ratio as actual divided by the design or catalog capacity. What are the factors or determinants that affecting the planned capacity? All items used in the production process, the facilities, the product, the process, the human factor, the policy, the operational factor, supply chain factors, some other external such as economic factors, and so on. The different steps or procedures in capacity planning starts with estimating the future requirements, future capacity requirements needed during the coming period. Then evaluate the current or the existing capacity, compare with the required in the future, and identify the gap, the deviation, the difference between the current capacity available and the required future capacity. Then identify different alternatives to meet or to cover such gaps. Conduct financial analysis to compare between different alternatives and include different qualitative issues also, factors that cannot be measured in numbers or numerical values. Then from the comparison, we select the best alternative for the long term, carried out or implemented, and follow up or monitor results, get feedback to recorrect the process from the beginning. Demand management strategies. What do we mean by this? As we mentioned, the capacity decision having the match or makes the matching between demand and the internal capacity required through some production process. So this means that we define the amount of production that matches the demand with the available capabilities. What are the different alternatives that an organization can use to make this match? We can make the match between the internal capabilities and the external demand through either changing amount of capabilities, which means capacities, or changing amount of demand. Since we match between demand and capacities, so we have two options, either to change the demand or we can change the capacities. What about demand? We have strategies used to offset capacity limitations and that are intended to achieve a closer match between supply and demand. What are the options that can be used to affect the demand, to increase the demand? We can use all the marketing decisions. We can use pricing through promotions, some discounts, and some other tactics to shift demand from peak periods into slow periods, trying to increase the amount of demand during the periods where it is low. So we change the very high demand into some other lower demand. We have some other alternatives that can be used to change capacities. Now, we have mentioned the option that can be used to change amount of demand. Now, we will talk about the options that can be used to change capacities. How can we increase our capacities through such a decision? Make it or buy it, in-house or outsource. Once capacity requirements are determined, the organization must decide whether to produce the product or service by ourselves or outsource it. What do we mean by outsourcing? Means buying the product or the service from an external source or supplier. So this means that outsourcing is considered as some external expansion for our internal capacities. If the used, for example, if the available machines are not enough to produce amounts to satisfy demand, we can buy some parts or components for the products from an external supplier, which we call it outsources. So the outsourcing is considered some expansion that can be used to increase our capacities. Factors to be considered for answering such a question: if we have to make it or buy it. For example, having some restaurant that sells sandwiches. What about the bread? Do they have to make it internally, make their own bread for sandwiches, or buy it from an external bakery? What are the factors to be considered? Available capacity. If we have all the required capacities for making such a product or part internally, so make it internally, not buy it from an external supplier. Expertise. If producing such a product or component requires some special experience and it's available, so make it, not buy it. Quality considerations. Mostly, if we have special requirements regarding quality that may not be available in the external product from an external supplier, so it's better to make it internally. The nature of demand. If we have some high level of demand that is consistent, it's not going up and down, that we are certain about such a high demand, by this we can make it internally, not buy it from an external supplier. The cost. Since the external supplier produces mass production, larger quantity, so their cost will be less. Otherwise, if we can produce it in lower cost than the external supplier, so make it. Risk of depending on some external source to satisfy our requirements of materials or parts or components. We have to consider the risk of not satisfying our requirement during the required time, with the required quality, or with the required cost. What do we mean by bottlenecks? Operation or managing bottleneck. Having operation 1 with capacity 20 units per hour that gives its outputs to operation 2, its capacity 10 units per hour, that gives its outputs to operation 3 that has 15 units per hour capacity. What do we mean by bottleneck? What is the maximum output rate will be produced? We have 20 units for the first machine, 10 units for second machine, 15 units for the third machine. The lowest capacity represents a bottleneck that limits the final output to be produced to be only 10, neither 15 nor 20. So maximum output rate is limited or will be limited by bottleneck operation or capacity of the bottleneck operation or the capacity of the lowest amount. This is called the bottleneck because it has the lowest capacity that limits the final output of the whole product line to be only 10 units per hour. Bottleneck is an operation in a sequence of operations whose capacity is lower than that of the other operations. Another figure, operation 1, 10, operation 2, 10, operation 3, 10, operation 4, 10, all of them are given to some assembly operation that cannot absorb the maximum of 40 units, the sum of the 4 previous operations, 10 plus 10 plus 10 plus 10, 40. The maximum capacity for this assembly line is 30 only, which means we have a bottleneck here that cannot absorb or cannot handle all the 40 units coming from the previous operations. So this is considered as bottleneck operation. We have some decisions related to optimal rate of output based on the cost of production. Having a graph on the x-axis, we will have the quantity or rate of output. On the y-axis, we have the average cost per unit. Per unit. This is not the y-axis, not representing total cost, but representing cost, average cost per unit. What about the cost per unit? As we increase the quantity produced, as we produce more and more, as the production quantity increases, what happens for the cost per unit? It decreases. As we mentioned before, the economies of scale, which means the share per unit from the fixed cost is going less. And this is why the cost per unit increases as we produce more. So for the first part, when we start increasing our quantity of production, the per unit cost decreases up till some specific point. Then, when we start increasing the quantity of production, the cost per unit will increase once more. So by this, we say this lower level or the lowest level or the minimum amount of cost represents the minimum average cost per unit, and this is the optimum quantity to be produced. Optimum Q to be produced at the lowest average cost per unit. So this graph represents the per unit cost as a function of increasing quantity of outputs. So we have to produce Q star or optimum quantity at lower average cost per unit. This is a graph representing production units that have an optimal rate of output for minimum output. So the first range of production from 0 up till Q or less than Q star is called economies of scale, where we improve our cost per unit, and the other half where the cost per unit increases is called diseconomies of scale. So now we have divided the graph or the range of production quantity into two parts. The first one represent economies of scale, where the cost per unit increases as we increase the quantity to be produced, and the other range represents this economies of scale, where the cost per unit decreases as we increase the amount or quantity of production. Economies of scale, as we mentioned, if output rate is less than the optimal level, increasing the output rate or quantity results in decreasing the average cost per unit. So in the economies, increasing quantity will lead to increasing the decreasing the cost. What are the reasons for economies of scales? As we mentioned, economies of scale, when we increase the quantity of production, the cost per unit decreases. Because of what? Fixed costs are spread over a larger number of units. Construction costs increase at a decreasing rate as facility size increases. Processing costs decreases due to standardization, having uniformity of aspects. These economies of scale, if the output rate is more than the optimum level on the other side of the graph, increasing output rate or increasing quantity will lead to increasing average per unit cost. Why? Because distribution costs increase due to traffic congestion and shipping from a centralized facility rather than multiple smaller facilities. Having one unit of production that all the outputs, the very large quantity of outputs are going out of such one central unit will lead to some traffic congestion. Complexity increases also the costs. Inflexibility can be an issue because having larger size of facility and additional levels of bureaucratic facility size and optimum operating level. What is the relationship between size of facility or factory and the optimum operating level, the optimum Q? Having on the x-axis quantity, the y-axis we have cost per unit, the same as the previous graph. Talking about small plant means producing smaller amount of production, very close to the 0 Q. So this is the smallest quantity of outputs. The rate of cost per unit decreases to some point, then it starts increasing once more. This is the previous graph. We have optimum Q for the small facility or factory. What if we buy medium factory or medium plant? Q increases. So we have the same graph but with larger quantity. Optimum Q for medium quantity achieves lower level of per unit cost. What if we use large plant? Quantity increases and optimum cost per unit decreases. So as we increase the quantity of each or the capacity of each factory, what happened for the cost per unit, it decreases. So the optimum quantity of the small factory achieves the highest cost per unit. For the large factory or plant that gives or produces the largest amount of output, it gives the lowest cost per unit. Can you see the relationship? The quantity increases from the small to medium to large. What happens for the cost? It decreases. The highest for a small factory, then the lowest for the large factory. As a general rule, as the general capacity of a plant increases, the optimal output rate increases, and the minimum cost for the optimal rate decreases. When capacity increases, quantity increases, and minimum cost per unit decreases. Evaluating alternatives. Alternatives should be evaluated from varying perspectives, economic perspectives, if it is economically feasible or not, how much will it cost, how soon can we have it, what will operating and maintenance costs be, what will its useful life will it be compatible with present personnel and present operations or not. The other very important factor to be considered, non-economic factors for the public. Evaluating alternatives, we have different techniques to evaluate alternatives using cost volume analysis, financial analysis, decision theory, and waiting line analysis. We will focus on the first technique,